settings are in there. Now I can click the stacking parameters and actually change them. The first, and these tabs will all pop up based on what you've got here. If you've got picture files, and that's all, you won't see, of course, the dark and the offset and the bias and all that stuff, flats. So the resulting image that it stacks up, what do you want to keep? I want to see standard mode. That's where everything is in the middle, where it just takes everything it can and gets the best square image it can. Mosaic mode, so you notice I don't have an image up here. The image would be black on the edge, and you'd see whatever images that you had lined up, it would put them up there. Intersection mode, you only get a result where you have that data point, that area of your image exists on all of the images that you stack. Standard mode usually works the best. Just so you understand, in the middle you'd have a whole lot of images stacking that data. You'd only have a few images stacking here. There will be nothing showing from these images out here. Now, drizzle is an odd concept, and you cannot use a digital SLR image with drizzle. The guy wrote this using 32-bit code, or excuse me, 16-bit code. It will not handle more than 4 gigabytes of memory. So if you have a computer with tons of memory, this is not going to use it. In fact, because of the way the Windows operating system works, it will only dedicate 2 gigabytes of RAM to this program. What Drizzle does, it takes a pixel and doubles it in 2 directions. Think of taking a chessboard, and every square on the chessboard, cut it in half in the X and cut it in half in the Y, so you have a square made of 4 squares, all the same color. Now, when you stack these images, the stacking actually will give better resolution, not at the pixel level, but at the 1/4 of a pixel level. And on a 3x drizzle, it would take 1 pixel and divide it into 9, 3 by 3 grid of 9 pixels. So what you're doing is you're doubling the size of the image in 2 different directions, or tripling the size of the image, and it has to be in memory to work. If you have an older camera that will only shoot like, what, 2 megapixels, you can probably do this. The Canon T2i and T3i that Wes and I and some of the other guys shoot is 18 megapixels in native mode, and when you're using 14-bit Adobe, that's a lot of stuff in memory. It won't do it. You can select a small portion and only stack a small portion of an image. You can drizzle that, but you can't drizzle the whole image. Now, if you're using a dedicated CCD camera that's like a 6 megapixel, some of the CCD cameras will actually do the drizzle for you inside the camera. The align RGB in the final image, simple idea. You know how we have chromatic aberrations, especially the red, green, blue are not always in alignment on the edge of your image. What this does is after it's stacked, it takes the red channel and the green channel and the blue channel of the image, and then it aligns those. It'll say the green is the reference. The red may have to be shifted 1/10 of a pixel up, down, or left to right, and the blue to line the center of the images back up where they need to be. And then, of course, we'll crop the edges. Now, here are the different stacking modes. First time you do this, just use the average. It's exactly what it sounds like. After it reduces all the noise, after it gets everything out and you're left with nothing but light, let it take the average of the stack. The median is actually pretty good. If you know anything about statistics, median will give you, if you have a lot of outliers, median might give you a better approximation of the central tendency of a stack of data, depending on how noisy the data is. But what's even better is this kappa sigma clipping. This kappa is the number, if you understand standard deviation, think of it like, Ron, you want to help me with this?
Not on this.
All right, well, standard deviation.
Standard deviation is all I got.
Well, one standard deviation, the average plus or minus 1 standard deviation, covers about 2/3 of your data. If you have an outlier in your data, say that you're shooting a black background, all of a sudden you get this pixel that's 128. Well, that's not supposed to be there. That's black. Why is it 128? It's an outlier. If the average of that spot in the data is, say, 5, and it measures how much variation there is in all the data, and 2/3, if you say plus or minus 2, ought to cover 2/3 of it. That's plus or minus 1 standard deviation. This piece of data is like 10 standard deviations away. It's got to be bad. Drop that pixel.
Alien intelligence.
What'd you say?
Alien intelligence.
Alien intelligence. So what this kappa is the number of standard deviations away from the average that you will tolerate. I usually set my data for a 1/2 standard deviation. The number below it, the number of iterations, is once it drops that data, do it again without that piece. Take another average, take another standard deviation. Is there anything else that needs to be dropped? Drop that one. Do it again. Drop that one. How many times do you want to do that? Well, that's what this kappa sigma clipping is. You're recursively eliminating noisy data that doesn't fit the average. Now, it ought to be intuitive now that the more data you have, the easier this is. If you've got 4 data points, 4 images, you really can't throw one of them away. You have 100 data points, odds are you're going to have a meteor fly through one of them, you're going to have an airplane or a satellite or something, a cloud, something fly through some of them. That's when this is handy, because it will actually cut an airplane completely out of an image, an otherwise image that you'd have to throw away. This will actually say, no, those pixels are no good. Toss those pixels, leave the rest of the image. It'll stack everything else, but it won't stack those pixels where that airplane is lighting up the sky.
How did you arrive at a 1/2 standard deviation?
Trial and error.
Okay, so you did do trial and error?
Yes, sir. I actually sat down when I shot, it was Black Friday 2013. I sat down, I remember because it was like 29 degrees. I was at Paul Grist State Park, and I took a picture of that comet, and I had 2 imaging rigs going, and I was out there to shoot with my short tube 80, nothing but M31 all night, because it's a huge thing, and I wanted to get it real pretty, And the next day, I was getting good results, but I wanted to see what some of this stuff would do, so I started thinking, let me try average, let me try median, let me try this number, this number, this number. Once it crunches all the data and saves that auto-save image at the end, it also saves an HTML file. You can go to that file and it will tell you which pictures which images it actually saved. It has all of the data in there about which pixels it thought were hot. A hot pixel, if you didn't know, in a camera is a camera pixel that is always as bright as it can possibly be. You put the lens cap on, it's still going to be 225. A black pixel or a dead pixel, no matter what you do, is going to be black. This will detect it, and it will average the pixels around it and replace that value with what it thinks it should be. Well, I went through this, and I came to, if I have a whole lot of data, I'll get rid of everything outside of 1/2 standard deviation. And I'll just run that number of iterations up to 10 or 20. It won't run 10 or 20 unless it needs to. Once it sees that it does that a few times and there's nothing else to get rid of, it'll go on to the next step. You can't set that too high and make it take forever to run. It works. So, median kappa sigma is the same thing, but instead of taking the average, it takes the median, which is the middle value. And if you take least to largest, whichever one's in the middle. Auto-adaptive weighted average, kind of sort of similar, but it weights the average based on how far a value is from the average. And this high dynamic range, entropy weighted average, if you shoot your images with multiple ISO settings, this is HDR photography. So the shadows will be made brighter, and the high-end brights will keep their resolution because you've got some values that are not maxed out. Some that are, some that are not. That's what this does. This takes more memory, takes a lot longer to run, but it works really, really well for something like galaxies, clusters, any of the faint fuzzy stuff. The really, really, really faint stuff. The maximum value is good for troubleshooting. I want to see the maximum value for every pixel when it aligns it. And I think this is what Webb Schwartz uses to pick up meteor trails. He'll run a stack of images and get a normal stacked image. Then he will take another image that he knows has got a meteor trail through it, stack those two together, keeping only the largest, the brightest part. I think that's what he's doing to get that in there. I'm not sure, but that seems logical to me. Once it is done stacking, it looks at the background, the red, green, and blue background, and it will actually bias the data down so that the background is as black as you want it to be. It'll use more than one method for how it calibrates itself. It'll either try to make the black a dead black, and X number of pixels makes each number, and they're even, or it'll try to bias it in a slope. And if you look at this, it's got a curve to it. That's rational. Linear, they're dead straight. I leave it on rational just because it gives you a wider variety of numbers. I don't like clear breaks between color. I like the nice even color changes. It's a lot easier to work with the data later. You can also calibrate the background. It'll look at the blue, the red, and the green. You can take the minimum, the middle of the three, or the maximum of the three, and it will shift all of the background colors. It'll bias the background to that point. I leave it none and rational. You have the same controls here for your dark to align and stack your darks. You have to stack your darks, you have to stack the flats, you have to stack the offsets. Once it stacks those, it takes a master dark, a master flat, a master offset, and the master is what it subtracts from each individual light frame before it stacks the light frames. Again, it doesn't matter what you use as long as you know what you're using. When I run a set of data, I tend to start with the averages with everything and then try the other ones. But with the darks, I've already got my darks. I pretty much know what they're going to look like. I will go with a kappa sigma clipping. Again, I usually use 10 iterations and half a standard deviation. Let's say that your darks, you don't have a dark that's 10 minutes long. Your dark library only includes dark frames out to 5 minutes. But you have a 10-minute long image. Well, how do you get that much noise? Odds are the pattern of noise won't change, just the intensity of it. You can multiply your darks by 2. Now it will take whatever that dark ends up being, multiply it times 2, and that's what it would subtract. So if you don't have a dark frame that matches a light frame, you can cheat a little here. I've never tried that, but that's what that's for. The dark optimization essentially means it takes all of your dark frames and it averages for each image, it'll average